Welcome to this Friday session where we'll go through BIM, our next version of the BIM engine, which is in beta release now.
Yes, and we have already shown it to a couple of our clients, and they are really excited about what have been presented. So we are looking forward to the rest now.
Yeah, and today we have with us Paul, which will demo for us some exciting stuff. You're with us, Paul?
Yeah.
Yes, then we'll go over to sharing the screen.
Good.
Okay, I'm starting out with a presentation to show sort of highlights of what is different in this new BIM engine compared to the previous one.
Yes.
Does it work?
Yeah, we can hear your screen. Go ahead.
So, so a bit of the background: the BIM models, the geometric models of the buildings that we mainly want to display, are quite big. So there's a lot of geometry. So because of that, we cannot send the complete geometry model to the viewer, the web browser in most cases. So we had to break it up. And the initial thought was, okay, we'll break it up by rooms, because if you're in a room and looking about, then what you can see is mainly in that room. So it seems like a very logical way to break up the geometry. So so this picture shows how we used to do it. So all of these red boxes are rooms in a story, in a building, and so we would sort of find out which objects belong in this room and in this room, etc. Rooms are really different in sizes, like some are really small and some are really big, and also it was heavy to process this to split it up like that, and yeah, a number of problems, like if you want to see the building from external, then the room based divide doesn't really help you. So instead, we're now started to think that we should split it in a grid, pretty much like the next picture shows. But not only a grid, so we also split it in several levels. So if you see the sort of large box here with this squiggly line around, that's the whole scene, the whole model, and then we divide that by 4, and then inside of that we divide that in 4 again, and the amount of levels you want to go down to depends on the overall size of the building or the scene. So
this scales automatically based on the size of the building? Yeah.
And well, typo there. And the thing is, so we by dividing it like this, there's a number of advantages. So we save the content of each of these into separate files now. So you have one file called 0 GLB that contains the whole or the box of the whole scene, but it doesn't contain every object in there. It only contains objects that doesn't fit inside of one of its children. So, for instance, the roof of the building is so large you cannot fit it into 00 GLB or 01 GLB or 02 or 03. So it has to go in the 0 GLB. Okay. And then further on down, like this wall section here will be in 00 GLB, for instance. And one advantage with that, compared to what we used to have to deal with, is that objects are only stored in one location. So like previously, objects that went across 2 rooms were stored in both rooms, and you had to deal with duplicates when you wanted to load both rooms and stuff like that. So yeah, and also this is a serverless architecture. So we store the files on Azre storage as blobs, and we don't need to, in order for the viewer to display something, we don't need to ask a server to provide some geometry, because the client code is able to figure out which one of these files it needs based on the position. So I can give jump over to the viewer just to show you how it looks.
Yeah.
And now we start with a map view, because depending on where you are in the organizational structure, you might be able to see multiple models.
Mm-hmm.
So for instance, here we have one in for the Nyko in Ørensvåg, and I set up one for Omega Lysaker. And if I double click the Omega one, we get into this story selector. You can select what story to view. And so if I now go here and start to go enter 3D mode, it loads the geometry around me, and it can do that because it knows what this position is, and then it knows which one of those cubes of geometry is around you. Another thing, and when I move now, it registers that, okay, I need some more now, but it knows which files to fetch, because it's a sort of a system of how these blocks of geometry are organized. And one funny thing is that it's actually the same as this map system. So when I scroll over like this, it needs to load new map data to the right.
Mm-hmm.
And that is also just a file store of map tiles. And this JavaScript knows whatever it needs to, what file names it needs to ask for. And when I zoom in, it's the same thing. Then you just have a different folder with a different zoom level, and the client is able to figure it out. So you don't need a server on the back end that will have to scale and stuff like that.
Yeah, cool. Is there so in the kind of new release now that we have some clients already testing out and using as this, it's the beta release. Is there some new benefits on the client side, the resources, kind of on the local machines, the iPads being used or machine?
Yeah, several things. First of all, when we have more control over which geometry to load, we can avoid loading too much, and we have had sort of memory issues with geometry previously. And I will also, at the end of the PowerPoint, I will come into another relevant new feature there, limiting the geometry even more. But yeah, so that's one advantage. Another one is this renderer used to render this picture 60 times per second, which used to take up a lot of GPU and CPU resources on your computer and consume a lot of battery, etc. But now it renders only when you move. So if I turn the camera, then it has to render, but now it's sort of idle because it can only display the same picture. It doesn't need to do that processing all the time. So that's another nice thing.
Oh, great.
I would like to show you if I go into the same model again now and look at the network traffic. When I enter it, it loads these GLB files, and this 0 GLB, that's the bounding box of the whole scene that I talked about.
Yeah.
And GLB is a standard format. So if I do open in tab on this one, it will put it in my downloads folder. And if I say open that one, it opens it in the Windows built-in 3D viewer.
Ah, cool. Because it's in the native format of 3D.
Yeah, it's one of the native formats.
Yeah.
So this one was probably, there's different files for different disciplines, but let me try this one instead. And this probably is the architecture. So this shows like the roof and the sort of concrete slabs here. They are too big to fit into any of the other smaller boxes. So this is what the 0 GLB file contains. And then, yeah, it goes on in detail beyond that. I'm going to pop back to the presentation. Also access control, so security, we have dealt with in this new version. So the sets of GLB files are placed in containers in Azure Blob. It's comparable to disks on your computer, like this is the C drive and this is the D drive. So the name of the container contains the model, which is your project basically. And then it's the revision of the geometry, and then there's an access code. So this means that you can set up rule sets so that some of the geometry falls into a different access level or access code, like 1, for instance, and then that will be placed in a separate container, and you can control who's got access to these different containers. So that means that we can control even down to single objects, but I think it's in most cases it would be per file. That's probably more relevant.
You get the flexibility here then, so if you would need to go down to an object or so that's a great feature.
Yeah,
big improvement.
Also, when we need a lot of the information from the IFC files from the BIM model in like the assets object register, and there's, in order to import that data, it's IFC BIM is a very flexible format, so objects can have all sorts of properties that are not predefined. You can sort of customize it in each IFC model. So we used to have one big table with like 50 columns, and that has been increased a lot of times, and it would have to continue increasing. So really not flexible. And then we had a mapping UI where you could map some of these what you're interested in from the objects in the IFC to these columns, but it wasn't really flexible. So now we've sort of pivoted it, turned it 90 degrees around, so that you have, instead of having a column for fire rating and for manufacturer, we now have a row for each of them. So that means we can, and now we import everything. So you don't have to make the choice up front before you do the import, what you want to import. We just import everything, so it's there available. And this performs quite well, actually, as well. So that's good.
Cool.
For importing or parsing the files, it's now 100% parallelizable.
Yeah.
So we used to run the parser on a single VM, and it did multi-threading, so you could, let's say, it could import 2 files at the same time, and then it would go on to the next 2 files, etc. But then we also had some bottlenecks, like the room index to place the geometry inside those rooms. We needed to wait until all files were parsed to know the geometry of the rooms, able to place the objects inside of them. So we had to wait with doing this until the end, and that really slowed things down. And the sort of scaling of this model wasn't really good. We have a huge VM now that it's really huge, and it's still really slow. And so now it's changed. So each parsing of each file is totally separate from the progress of the other files. So you can use Azure Batch, and each node can run multiple files. I think we have tested with up to 8 or something per node, and you can have multiple nodes, so you can do really efficient imports of the whole thing.
Have you done any like measuring of doing it the old and new way and the difference in performance?
Yeah, not much, but we did a test on a quite big project, and that used to take 3 to 4 hours to run like this, and it run in 3 minutes on the new one.
That's what I call a huge improvement then, huh?
Yeah.
Oh, that's great. And then good thing with this Azure batch and nodes or containers where it, as you said, fully parallelized and you scale horizontal based amount of models you need to parse. There's no limit. Of course, Azure is the limit, but we know they are huge, big, so that's good.
Yeah.
Yeah, and the cost as well, because I think this VM runs continuously, but these will start up whenever you need them, and you pay only for the runtime. So they are probably quite expensive, but if it's quick, then they won't run for that many minutes. So
cool.
Also, when you started the parsing process, we could have improved that with the old model, but there was very little feedback to the BIM admin on what's going on. So pretty much a black box. You say you want to parse some files, and you just wait, and maybe the next day they are parsed. So we've improved the UI, so you get a progress indicator on each file, and if you click the file ID, you also get a detailed log of the progress. So just a small improvement, but I think it's actually quite important for the users.
Absolutely. Getting this feedback and knowing the status, especially if you're going to start working in that model, you can plan for when to start.
Yep. It's the same. So this is revisions. There's the screenshot here only has one revision per model, but so you can also you have one revision that is approved, and then you import and you sort of prepare a new revision, and once the BIM admin decides this is good enough, they can say approve, and then that becomes available for the rest of the users. We had the same in the previous version, but so the functionality is still there.
Yeah.
But then this thing is also quite important for us technically. It's going to allow us to limit the amount of geometry we need to send to the browser even more. And that is, for instance, if you work with the water and the ventilation and stuff like that, then you are mainly interested in that, so you're not interested in the electrical stuff. So we can define sort of queries, criteria, where we say that, okay, from the architectural model, you're interested in walls and ceilings and floors and stuff like that, because you need to be able to see where you are in the building. But we don't need doors and windows and other things. And then in the VVS model, you can say, okay, we're interested in this and that. And then we will the server will process and generate a separate set of those GLB files containing only those things that match your query.
Oh, okay.
And that means actually a lot of things. It means that we can limit what we send, so we only send what the user is interested in. Also, the BIM coordinator will be able to set up access based on these partitions. So so you could say, okay, one of the suppliers will only get access to this orange one. They cannot see the full model. They will only be able to see what's relevant for them. Also, if when working in situations where we have to support offline, you can choose then to download this partition basically, and that's a limited set of files that you can download to a tablet or something.
So there's multiple benefits here then, both from an end user to create himself partitions, filters, so to only see what you need to see, you get that access part where you only should limit to what they are allowed to see, and then the offline one was a good example where you want to go offline, you don't want to download everything, only what you need to work on.
Yep.
And do that. So.
And then another one, which is basically where this came from. The idea came from Roger Arnesen, and his perspective was a totally separate one. This is focusing now mainly on the technical, but if you partition it into like a work package or a control area, then this partition will get a number, and you can then do sort of if you're doing discussions or what is that in Omega? You have this panel on documents and stuff where you have yeah, you can do collaboration, and you know what you're talking about. So you can sort of limit the collaboration discussions on that specific thing. And so this is where it really came from, and that will be a huge advantage for the users.
This can be really powerful, I think.
Oh, great. And this is in alpha in our beta.
Yeah.
It's in the cooking. But that was the bit of the purpose of this today's session. Throw out what we are working with, so our fellow employees and clients can get some insights.
So, and I don't think we can put out any dates, but when do you think we can be coming into a pilot or production here, like in a few months?
Yeah, so we started with some clients testing it out, and we will be starting rolling out this as a side feature into all clients. So to get that going, that's a project that Paul and Jan Leon started, and really exciting to get this out in production.
And so I think this viewer is now missing a lot of the functionality that we already have in the previous one, but that's just more sort of a copy paste. We have focused on the basis right now, so we will start moving across the possibility to attach issues and stuff to objects pretty soon. So but we know we can do that, so the main focus has now been on the new architecture.
Okay, but this was really good. We get deep insight, but also some quick insights into how our next release of BIM is going to be, and what we have done in order to increase performance, scalability, which has been kind of a huge improvement to the product.
Yeah, for sure. I'm really excited. I think this is really gonna put us in the next level now. We see that again, the clients really love this. They see that this will increase the quality of the product.
Yeah.
So exciting.
Okay, that was really good. Thank you, Paul, for showing us.
You're welcome.
And then we will see you next Friday on a new session.
Yep.
Okay. Bye bye.
Yes.
Bye. Cheers.